Hello everyone, myself Dhaval Thakkar. Currently, I am a lead software engineer at Salesforce, and here I am presenting very innovative approach of managing mobile machine fleet. So basically, what I am doing, I am integrating GPT-powered conversation with IoT edge computing. We will see that into detail. So, what problem statement I'm trying to solve? So, right now, if you see, management of mobile machine fleet is very complex task that involves challenges like equipment breakdown, insufficient operation, and safety concerns. Such challenge can lead to costly downtime, accident, increased maintenance expense, and many other things. Uh, Actually, mobile machine fleet, mobile machine is a very big industry and very impactful industry, I can say. Uh, Construction, logistic, and many other. So, mobile machine fleet are the backbone of various industries, as I said, and their efficient management is critical for productivity as well as safety, right? So, what we need to do for that, we may require real-time monitoring, on-time maintenance, safety measures. All other things are very vital and very important for the business. So here is my solution to address those challenges. So my solution is leveraging power of LLM. We know everyone is talking about LLM, Chat GPT. So let's see how we can leverage that into this particular solution. And I'm combining LLM, power of LLM with the innovative approach that offers real-time safety and telemetry monitoring, remote diagnosis, condition-based monitoring, and AI-powered user assistance. So following are couple of primary key features and other features for this particular solution. First, so safety monitoring, very important. Uh, Safety is a number one thing for any business. And here in this particular solution, I am monitoring various sensor telemetry at edge. We will see into detail what basically edge is. And also, I am providing, the solution providing real-time diagnosis of equipment issues by analyzing sensor data from Raspberry Pi. Currently, I'm using Raspberry Pi as a microprocessor for it. Then condition-based monitoring. So basically, the solution will continuously monitor the machine, and based on the condition and based on the telemetry data it receives, it will run the intelligent algorithm on it at edge uh, on the Raspberry Pi. I am integrating LLM for improving fleet management experience. We will see what it is in upcoming slides. So, if I talk about technical implementation, right now the whole system is divided into a six main layers. So, if you see here, uh, I am using ESP32. It comes with Wi-Fi and Bluetooth. Uh, I am using it with this vibration sensor, and this is a temperature sensor, waterproof temperature sensor, and I'm considering it as a sensing layer. And I have a Raspberry Pi. uh, it is a, we can say, edge computing layer. So basically what we are doing here, uh, sensing layer, basically ESP32 will sense the temperature, vibration, and GPS coordinate as well. I also have a GPS sensor, but as I am sitting inside indoor, uh, it will not going to accurate, or it will not going to provide you with the data. So basically we can, right now for this particular demo, I am considering temperature and vibration sensor. And edge computing layer, as I said, I am using Raspberry Pi uh, as a edge device, and I written some custom Python module, as well as I'm using Azure Stream Analytics module. So if you see here, this is my custom module. Python, written in Python. Basically, what it do, it uh, reads the data coming from sensing layer from ESP32, and it will send those data to this to Azure Stream Analytics job. So basically, one job is for temperature telemetry and another is for vibration telemetry. So right now I'm sending data from ESP32 to Raspberry Pi in this custom module through MQTT. So basically, sensing layer will ESP32 will send this telemetry over MQTT, and Raspberry Pi will subscribe to that topic and uh, will send those telemetry into this uh, Azure Stream Analytics module. So everything works at edge. You don't even need an internet connection for that. That's amazing, right? So moving forward, uh, to do the analytics, you don't need an internet. Uh, but let's say there is some anomaly, uh, high increase into temperature or vibration detection. Uh, in mobile machine fleet, or let's say very heavy machine, temperature can be a very critical part. Uh, let as an example, engine temperature or some other temperature for those particular big machines, as well as sometimes vibration is also important and critical part of running those machines. So what Azure Stream Analytics do, they will try to figure out if there is any sudden increase into temperature or vibration for this particular machine, then it will send that. If it identifies that or if it detects that, it will send that to the Azure Event Grid. And basically, Azure Event Grid is capable of sending or scaling millions and millions of events, and it will send those events to a target. So right now here we have a target. I am calling it Action API. Basically, it's just a webhook. So basically that webhook subscribes to the event grid topic, and then store that data into database, anomaly data into database, as well as uh, it takes the reactive action like sending email to the fleet manager, something like that. I also have a fleet management portal where fleet manager can manage all the machines through the portal, as well as fleet manager can see the visualization, different telemetry, anomaly, and all. We will see in upcoming slides, and I will have a demo for that as well. And I have a data layer. So I'm using a Postgres with the timestamp extension, because we are dealing with time series data, right? So we need something like timescale extension to effectively handle those telemetry. And I am also connecting Postgres with Hasura GraphQL engine for interactive data visualization and all. And interesting part is LLM layer. So I I am using LangChain's SQL chain, and I am connecting that with the GPT 3.5. So basically, what it will do, GPT Chat GPT API will get the prompt or the question from the fleet manager, from the uh, fleet management portal, and it will chain that particular prompt or the question to the LangChain, and LangChain has capability to generate the SQL chain from that prompt. So as an example, if if fleet manager wants to understand the maximum temperature of any particular machine, uh, he or she just need to type what is the maximum temperature of machine XYZ, and basically this LangChain and SQL chain, and this particular model basically will figure out what query it need to run and how to represent the data to the user basically. So if we talk about the architecture, we already discussed that we have a sensing layer. We are using right now we are using couple of sensor and edge computing layer on Raspberry Pi, installed with Azure IoT, Microsoft Azure IoT Edge Runtime, along with Azure custom edge module that reads the data from sensing layer over MQTT, and we also have couple of Azure Stream Analytics job. And so basically, Azure Stream Analytics job will send the anomaly if it detects to the Azure IoT Hub. Then Azure IoT Hub will have the subscription created in Azure Event Grid. Basically, subscribe to the event and send, I mean, creates the action or interacts on to those events coming from Stream Analytics job. So right now it is sending those anomaly into database, as well as it is also sending email. Uh, Hasura GraphQL, as I explained, using it for uh, interactive visualization on the portal. So basically, this portal is a React.js app, and as I said, uh, connecting ChatGPT with the LangChain for uh, SQL chain for converting natural language prompt into SQL uh, queries. So if I talk about value proposition of this particular solution, it can be many. I listed few of them. Reduce downtime because it predicts the maintenance, minimize unplanned downtime, ensure that machines are operation and working as expected through all the data coming from Raspberry Pi sensors. If it detects the anomaly, then Fleet Manager can react on that. Enhance safety. So safety monitoring is a part of this particular solution because it is detecting critical telemetry coming out of machines. It can be vary for different industries, but mostly for heavy machines, temperature and vibration can be a critical telemetry coming from those machines. Cost saving, uh, remote diagnosis, reduce maintenance cost, as well as extends the equipment lifespan if we can able to uh, react on those particular conditions immediately. Optimize efficiency, condition-based monitoring allows for more efficient resource allocation, and as it is doing all this thing at edge, so it will not need that much of bandwidth and internet connection and all. Even if a machine or the truck is in very remote area having a very less internet connection, it can work and it can detect very good amount of uh, data insight from those sensor data. Real-time user assistance, uh, the magic of integrating chat GPT along with sensor data can be a magic for machine fleet management industry. Also, it helps user, or I can say fleet manager, with many other things like they can get the run book or manuals for those machines easily by interacting with the chat GPT or any other LLM. Feasibility and uniqueness. This solution is very well feasible. It is leveraging microprocessor and controller, and most of the solution or the sensors we have in the market, Azure Edge Computing, or I can say IoT Hub, is very much compatible with those. And we are also uh, doing AI-driven technologies for user support. Uh, we have many things going on around artificial intelligence space, LLM, language model, and also everything is there. We just need to integrate that, and we need to come up with some innovative idea like this. So, what can be the unique differentiator for this particular solution? As I already say, it's innovative approach of managing machine fleet, as we are integrating with LLM, and as well as we are running all this analytics of the sensor data at the edge. So it's a kind of innovative approach compared to what fleet management softwares and other tools that we have in the market right now. Impact and sustainability, it has a very it can have a very big impact on sustainability considering the environmental, because it reduces the downtime, efficient use of resource, as well as it is not using that much of uh, I can say electricity, and also carbon consumption is very less. Social impact as well, because it enhances the safety measures, and it is s- safer for work environment like heavy machine industry and all. Economic for business, cost saving and improved efficiency. If business can able to detect the problem earlier, then it can save uh, monies as well. Uh, so let's jump into a demo straight away. So as we discussed, this is a custom module running on IoT, Azure IoT Edge module, Raspberry Pi. So for this demo, we will do the vibration uh, demo. So this is a vibration sensor. So if I do a vibration here on this particular sensor, you will see that we are seeing the vibration here in this particular telemetry, and this particular uh, will sense that, and as you see, I can see the alert directly coming into my email. So let's also go through the portal, fleet management portal. So here if you see, we have a portal that list all the machines, available machines in the database. So basically you can see that machine detail like type of machine, if the maintenance is scheduled or not, last maintenance date, and current location as well. Right now it's not updated because this GPS sensor will not work indoor, but it definitely works if you go outside. So these all things are uh, related to the IoT sensor telemetry and all, but the innovation and the interesting part comes here. So you can directly talk with your data, your machine. So let's say if I want to understand, mm, and I want to see, uh, let's say how many or how many machines we have. So basically, it will so call the OpenAI ChatGPT uh, model 3.5, and the LangChain will able to sense uh, the prompt and will try to figure out what query it need to run on the database to get the details. So here you are seeing that there are 5 machines in the database. Very simple answer, nothing complex. So let's do one another thing. Let's say let's find the average temperature for machine 1. I am asking what's the average temperature of machine 1. So here you can see the average temperature of machine 1. It will do all this analysis based on the timestamp DB. So tumbling window and all will come into picture. So it will be giving you the last three, I mean, the three average for last 3 hours. Every hour it will calculate from every hour it will calculate the average. Uh, let's ask to schedule the maintenance for machine 2. That will be interesting, right? You don't need to go into any system, or you don't need to deal with any complex system. You can just ask set schedule main for maintenance for machine 2 to Okay, here you can see identify what query it need to run on the database to update the maintenance is schedule or not. So it's very powerful as well as very smart. Uh, Also, now you will ask me about what about my data privacy and all. So here's the thing. Right now, I am using ChatGPT 3.5, but you can come up with your own LLM model and you can deploy that. So right now, if you see in market, there are many open source LLMs available. You can pick one of them and deploy in-house in your data center or on the cloud where you have your all the system and all. So there are possibility to do that as well to deal with the data privacy and all. So that's about this system and a brief introduction about me. Uh, right now I'm working as a lead member of technical staff at Salesforce and I'm working as a uh, platform infrastructure developer, but I have interest into IoT, edge computing, and AI, ML, and all that stuff. So that's why I'm exploring all these things, and that's why I'm bringing this innovation solution that can be beneficial for many industries for managing their mobile machines. Okay, so that's all from my side. Uh, Thanks for listening.